Okay, and let's to continue for example. Another example for you. This example is the similar. We will find the data. The diffraction at the point C, and the point C is in the apply the concentrate rule on the C point. So we will find the diffraction at the position of the force. Okay, let's start. This is also example for integration. Example for integration. I think this method is very important in order, but you need to if you find I think number one is a distribution load. Two type of loading, and the second is a concentrate load. So two different kind of loads. One is a concentrate load, another is a distribution load. But the method is almost the same. And this is a find. The method is almost the same. Find a common equation. Find the common equation. And then on the find boundary condition. Find the boundary condition, and we can get the solution. So only 3 procedures, and you can get the solution. So very, very easy. But I think much more complicated is for the concentrate load, and maybe more easier for the distribution load. Okay, let's start. And in this case, we need to calculate the reaction. The reaction force. I think it's very easy for you to calculate the reaction force. So I don't want to calculate for you because for the reaction force, it's very easy for you to calculate. Okay, so when we get the reaction force, so we need to separate into, because here we have a loading change. That means we have a loading change here. Loading change. The loading condition already changed here. So we need to separate into 2 partitions here. And the first part is here, and the second part is here. So we need to, that means part 1 and part 2. We need to separate into part 1 and part 2. Okay, part 1 and part 2. So for the part 1, and the part 1 is the shear force. I mean here capital V is a kind of shear force, and the shear force is always equal to minus P divided by 2. Is when the 0, the X is between 0 and the X and the L. And the second in the second partition, the Vx is equal to P when L is X is between L and 2/3